Yes, good morning class. I am audible.
Good morning, sir.
Good morning, Himanshi. Manish, how was the exam?
ठीक था सर.
ठीक हो गया?
Yes.
All other students, आपका एग्जाम कैसा हुआ? Yes, class. Yes, we will start in a couple of minutes. Let the student join us. Yes, CSC fifth day students, how was your exam? I am audible, class.
Yes, sir.
Okay. कैसा हुआ एग्जाम सिमरन?
सर ठीक ठीक हुआ है.
ठीक ठीक हुआ है. क्यों?
सर जब चेक हो गए तब भी पता चलेंगे. अब आंसर्स कुछ मैच नहीं हो रहे थे. मेथड तो सही था, बाकी लास्ट में आंसर नहीं मैच हो रहे थे.
ओके, चलो आपको मेथड के नंबर तो मिलेंगे ही, राइट? अगर आपने मेथड सही लिखा है, नो इशू. मैथमेटिकल एरर है, दैट कैन बी इग्नोर्ड ना. उसके कुछ कुछ नंबर तो कटेंगे डेफिनेटली, बट ये नहीं है कि पूरा जीरो हो जाएगा. यस, वेयर इज मोहित? Sujata, are you there? Okay, so I am resuming from my previous lecture, in which we are talking about multiple access protocol, right? Yes, class. Screen is visible to you.
Yes, sir.
So we have ended our lecture, in which we are talking about these protocols, and we have segregated this protocol into three categories, right? So we have already discussed Aloha, and Aloha have two categories: pure Aloha and slaughtered Aloha. We are talking about CSMA. In today's lecture, I'm going to again discuss the Aloha and some numerical. Right. So please focus over here. First of all, what is random access? So we don't have a dedicated medium, and that medium is basically shared among multiple stations, and all those stations have some packet to send, and they need some communication medium. We all know that. But the problem is that communication medium is shared among all the station. Now there will be a contention because of that, right? That's why it is called contention method. So all the station, they are in a queue, or they are in hurry that I have to access the channel first. And because of that, what is happening? There is a collision of packet, because if any two station start communicating at the same time, or if their frame transmission time is same at any instance, then that packet which station is transmitting is useless, right? And that packet is basically get collides. So collision take place. So
Good morning, sir.
yes, good morning. For this reason, we need a method, and that's why first method that we have is known as random access. So no station is superior. These are some assumptions that we have to take, and you can see none is assigned a control over another. So every station have right to send a packet at any time. In this category, we have Aloha, we have CSMA, we have CSMA CD, we have CSMA CA. Now you can see the above three protocols, these are for wired network, but initially Aloha was designed for wireless in Japan at the University of Hawaii in 1970, right? So I'm just going to highlight the things that we have already discussed, and now you can see this the dotted line in between. These are the channels which will be used by the stations. Here we have, in our example, we have 4 stations. We are going to access this channel. Now this channel can be accessed by any station at any time. Now what is the problem with that? If any two stations start communicating at the same time, as you can see in this particular, where frame 1.2 and frame 2.1, they have a common transmission time frame here, and due to which the entire frame get damaged over here of station 1 and station 2, and station 3 also, which is in the time slot of that same frame. You can see here the station 3 has begin his transmission before station 2 and station 1 and station 4. But when this frame is close to the ending, you can see another station has started. And when this station has his frame close to his ending, then another station has started, right? So this is the vulnerable time. You can see here we will talk about that vulnerability. So this is the vulnerability, the risk that station have for their frame to send, right? So what is needed? We need some method in which we can able to send successful transmission. And how we can achieve that? That is the main important thing that we are going to achieve. So initially Aloha was designed, but this protocol was not so popular, and this protocol is not in use now, and it is not practical actually, because the efficiency of this protocol is very less. You will see in the next slide why I'm saying this thing. Now you can see this station 1.1 frame and station 3 3.2 frame, which does not collide with any other frame. So during this time, so what will happen? This frame gets successfully delivered, right? You can see the maximum of the thing, the maximum of the frames get collide over here. Collision, you can see the duration over here in 2.2 and 4.2, station 4.2. See, so this is the problem with pure Aloha, that efficiency is very less. And why efficiency is very less? This can be taken by this formula, that is S, that is throughput. If we talk about the maximum throughput, where S is equal to G into E ki power minus 2 G, where G is the load factor, right? And E is the value, that is 2.71. Now we substitute the value and we will consider G. So we can find that any station here, you can see that the vulnerability for that station whose frame is being transmitted for the time is 2 into T frame. So because of this 2 into T frame, so maximum throughput when we will get? When a station will get this 2 frame window for their packet to send, then only that particular station can successfully transmit. Otherwise, this is the risk for a frame to be get collide with another frame, right? Now suppose you can see any station begin its packet at time t, and another station which is already being sent or already sending its packet at time t minus tf frame, right? And another packet which started at t plus t frame. So if we subtract from maximum to minimum, what we will get? The t gets subtracted and we will get 2 into T frame, right? So this is the vulnerability time is more in case of pure Aloha. Please see this thing. This is very important, right? If you have any doubt, you can ask on this. So that's why we are taking G over here, that loading is half of this. So when we will put half of this value, we will get the maximum throughput, and the maximum value that will comes out is 0.184, right? So in pure Aloha, the station to transmit data at any time, whenever they want, because this is the only protocol which was designed with no rules, right? So any station can send at any time, and after transmitting the data packet, station wait for some time, right? So in this we have two cases. Case one, that transmitting station receive an acknowledgement from the receiving station, no issue, there is no problem, there is no collision. In this case, you can say the transmission is successful, right? So this is the case one, when the transmission is successful. Case two, that can be that station does not receive acknowledgement. If station does not receive acknowledgement within the specified time, then what we will say, that is a unsuccessful transmission. And basically that leads to inefficiency of the network, right? So what will happen? The transmitting station use, so as where we have talked about that there will be some random, this back of time BT, right? So the station will start resending the packet after this back off strategy, that is the back of time TB. If there will be a unsuccessful transmission, then station will wait for this back of time, that is some random amount of time, nothing but back of time is some random amount of time that will be calculated, as you can see in this. That is, TB can be calculated as R into TP or R into the transmission frame, right? So what we will have that after that back of time, it transmits the data packet again if there will be unsuccessful transmission, and if it will keep on trying. And for how much time it will keep on trying, we have kept that value also 15 in our previous example. You can see that value is 15 over here. So that is our value, that maximum value for which we have to keep on trying. That's why we have started our counter from k is equal to 0, right? And up to k is equal to 15, we will keep on trying. And when we will exceed, then we will simply exit the program. It means that there will be some physical damage in the path. So that's why, or the router is damaged. That's why we are not able to reach. Otherwise, this will be a case of infinite loop. We keep on trying and we keep on fail to send our transmit packet. So unnecessarily we are wasting our energy. We are wasting the bandwidth. So that's why it is saying that it keeps trying until the back of time it reaches, after which it aborts the transmission. Means we have reached the maximum limit, and after that maximum limit, now the transmission is still not possible. It means there is some severe issue in the network, and that's why we are not able to transmit the packet, right? So that's all about pure Aloha. And then we are having another category in Aloha that is known as slotted Aloha, in which we make some rules. As you can see, there is no rule in pure Aloha. Any station can send at any time, and because of that, there is a contention in the network, and the stations, they are start transmitting the frame, and due to which there is a collision in the network. How to avoid this thing? In this direction we are working, right? This is our strategy, this is our objective of learning this particular topic, that how to avoid the collision, how to minimize. Please remember this thing, we cannot able to eliminate, we can able to avoid, but we cannot able to eliminate completely, right? Collision will definitely occur if you have a high class or state of art network architecture, then also there will be collision. As you can see, like we are having a very express highway roads, still collision will occur, right? Similarly in our network also, if we have a state of art network, then also there will be collision, right? We cannot avoid, we cannot completely eliminate, right? But yes, we are working on this direction, that we can able to minimize the level of collision, right? So in that direction, first protocol was designed, that is known as pure Aloha, for multiple access, because we are having a common shared network channel between the sender, multiple sender and receiver, right? So which station will access the channel first? Who will give this priority? And as in the beginning, we have already taken the assumption that no station is superior with another station, and no station can control any other station. So every station have its own independent decision for sending the packet at any time, any time, right? So problem is that station can access this channel, this common share channel, at the same time, and because of that there will be a collision, and that we need to avoid, right? So the next is slotted Aloha, in which what we done, we have a discrete time slot. You can see this is discrete time slot, 0 1 0 1, you can say like this. We having a discrete time slot. In this discrete time slot, we are sending our frame, and we have set one more rule. We have set two rules. First rule says that the channel will have some discrete time slot, and second rule says that the station can able to send the frame only at the beginning of the time slot. You can see station can send only at the beginning. No station is sending in the middle. In the previous case, in pure Aloha, you can see the problem, the vulnerability is there. The station is sending in the middle of the frame. You can see this one. Here, the middle of the frame they have started. Here also. Yes, so vulnerability is 2 into time frame. That's why. Yes. Here also you can see in the middle of the time frame. So this basically, this particular rule only improved the efficiency to 18%, improved to 18%. So initially we are having 18%. So 18 plus 18, that's why we are having the double of the pure Aloha. Slotted Aloha having that throughput 2 times of, right, pure Aloha. So you can see 18 plus 18, that's why it is coming to 36%. And we are having the value of G over here is 1. Since the vulnerability is reduced now, vulnerability is 2 into TF in case of pure Aloha. Yes, but in case of Aloha, slotted Aloha, we have vulnerabilities into TF. We have taken over here, right? So you can see the vulnerability, the vulnerable time, because we have set that now the station can send the frame only at the beginning of the time slot, and here the time slot is not continuous as we have in case of in pure Aloha. Here the time slot is discreted. We have divided the channel into the time slot, and we have fixed that station can send at the beginning of the time slot. No station can send in the middle. You can see. Yes, collision is still there because 2 stations can start at the same time. Here station A and station C, they begin their packet transmission at the same time. So yes, collision is again there. We cannot say the efficiency we are getting 100% in this case also. So in case of slotted Aloha, the efficiency is improved from 18% to 36% because of this reason that station can send only at the beginning of the time slot, and the channel is divided into discrete time slot. These 2 particular rules basically improve the efficiency. So slotted Aloha divides the time of share channel into discrete interval, as I told you, called as time slots. Any station can transmit. We did not change this particular. We put it like this only because we don't want that any station can control any other station, and any station is superior with any other station. We don't want that thing. So we kept this thing only, that any station can transmit its data in any time slot. There is no restriction for that. The only condition that station must start its transmission from the beginning of the time slot, as I told you in the previous slide also. So you can see station B, and this is our time slot beginning and end. So station can start at the beginning of the time slot. Now your question can be, any 2 station can start at the same time? Yes, definitely. Any 2 station can start. You can see station A and station B, they can start at the same time, and they have collision because of this. So these 2 packets will not able to deliver successfully. So there will be a retransmission in this case, right? So we will see the next point, that if the beginning of the time slot is missed. So here you can see here station B and station A have they have missed the beginning of time slot. That's why they are not able to send in the middle, and then they opt for the next discrete time slot they have, and unfortunately these 2 stations, they have started in the same time, and this led to collision, right? So that's why it is saying that if the beginning of the slot is missed, then the station has to wait until the beginning of the next time slot. You can see for station A and station C, the beginning of the time slot is missed, suppose. So they cannot now able to send in between, as they can able to do in case of pure Aloha. Yes, but the efficiency is very less in pure Aloha, as you all know. So collision may occur if 2 or the more stations try to transmit data at the beginning of the time slot. Yes, any doubt, class? So now talking about the important question from MST point of view, please take the screenshot of this, that is pure Aloha and slotted Aloha. So as I told you, any station can transmit the data at any time, where the time is continuous and it is not discreted. We have taken discrete time in case of slotted Aloha, and you can see that station can send at the beginning of the time slot, right? So if we are talking about discrete, So we need one more concept in slotted Aloha, that is synchronization. We need to synchronize the time slot between the station, because if station are not knowing that what is the beginning of any time slot, then they are not able to send the packet in a proper manner. There will be no fixed pattern of sending the packet. So there will be, it will be a simple case of again pure Aloha. So we need synchronization, right? Global synchronization between the station which are sending the packet in slotted Aloha. Whereas there is no need of a global synchronization. You can see the time is continuous and there is no global synchronization is needed between the station, right? Now, as you have seen that the vulnerability time is 2 into transmitting frame, and whereas in slotted Aloha it is TF, that is transmitted frame, right? Then talking about the efficiency that can be raised by the Poisson distribution curve, and from that probability of success transmission of data, we get from the derivation we get this expression, that is G into e raised to power minus 2g. Whereas for slotted Aloha we have 1 over here. You can see that G 2 is not over here. Here we having 2g, here we having only g, right? So efficiency, we have calculated the efficiency where the overload function G is half in case of pure Aloha, and in case of slotted Aloha it is 1. So that's why, and that is a major difference between pure Aloha and slotted Aloha, that the efficiency is double in slotted Aloha because of putting these two points, right? These two particular rules in slotted Aloha will lead to efficiency the double of pure Aloha, right? So you're talking about the main disadvantage of pure Aloha is that the efficiency, and if we talk about the advantage of pure Aloha, that is simplicity. Since we are not putting global synchronization, we are not dividing into discrete time slot, right? So any station can send at any time. There is no such rules in pure Aloha. So that's why that is the main advantage we are saying over here, that it's simplicity. It is very simple, but it is not practically used anywhere now, and we are not using it. It was the since it was the first protocol in its research, in this research, so it having many you can see disadvantage, as of you can that efficiency is very less. So we are not using it right now, right? Whereas slotted Aloha, the main advantage of slotted Aloha is that it reduces the number of collision. Since we have used the discrete time slot, and we have said the station can send the frame only at the beginning of the time slot, not in the middle of the time slot. So basically it leads to the double the efficiency of pure Aloha. Yes, any doubt you want to ask, you can ask. Someone has raised the hand. Yes, please. Navjot, you want to ask something, you can ask.
Yes,
Please ask. What is your doubt?
no doubt, sir.
No doubt. Some has raised the hand actually in between. I missed that one.
Say it's by mistake. Say it's by me, but it's my mistake.
Okay, Navdeep Kaur, you did it, na?
Yes, sir.
Okay. The thing is clear. I think the difference is clear. Pure Aloha and slotted Aloha. Yes. And
Yes, sir.
please remember this this formula, that G into e raised to power minus 2g for slotted Aloha, and for pure Aloha, and for slotted Aloha it is G into e raised to power minus g, right? And the efficiency of pure Aloha is 18.4%, whereas the efficiency of slotted Aloha is 36.8%, right? Now please I'm putting this thing in front of you. Can anyone tell me, or can anyone read this line? Yes, class. Anyone?
Yes, sir.
Please read it out.
Yes,
A
sir, I can read.
slotted Aloha
Yes,
networks
continue.
transmits 200 bits frames using a shared channel with 200 kbps bandwidth.
Hmm.
If the system, all stations put together, produces 1000 frames per second,
then the throughput of the system is.
Throughput of the system is, yes. Yeah, we have seen the formula for throughput in the previous slide. Yes, anyone can answer this question. You have 2 minutes. You can answer this question. It is slotted Aloha. So efficiency will be, yes, anyone? In case of, please remember, in case of pure Aloha, this is 2. Whereas in case of slotted Aloha, it is G into e raised to power minus G. Right? In case of slotted Aloha. Yes, anyone? Yes, right now only we have talked about this thing. That in case of slotted Aloha, efficiency is 36.8. Yes? Yes, Bharat, are you there? Kulwant? Please note it down. For pure Aloha, the formula is what we have, and for slotted Aloha, what we have. It is maximum, we all know, it is maximum when the value of G is equal to 1. And in slotted Aloha, in pure Aloha, it is maximum when the value of G is 1 by 2. You can see this is written. The maximum efficiency occurs at G is equal to 1 by 2 in case of pure Aloha. Please remember this particular point. This is very important for your numerical. These 2 points. Right? And whereas in case of slotted Aloha, the value of G, that is 1, it is maximum. The maximum efficiency is 36.8% when G is equal to 1. So the same thing is I have put on over here. Right? You can see. So we have set the value of G, that is, since it is slotted Aloha, the maximum value of G is 1, right? We substitute the value simply. We get the efficiency, that is 30.368. We convert it into percentage. So it will be how much? It will be 36.8%. The next question I am going to put in front of you. A pure Aloha. Yes, anyone can read? Who will read this problem? Yes, the correct answer is already I have shown over here. That is B. That is so a pure Aloha network transmit 200 bits frame using a share channel. Okay, so we having a common share channel between the station. These are the station, right? And we have given that using a share channel with 200 kbps bandwidth, right? If the system, that is in this system, if all the station put together and produces 500 frames per second, then the throughput of the system will be. So we all know that in case of pure Aloha, what we have is the throughput can be calculated by the formula G into e raised to power minus 2G, and we all know that in pure Aloha, the maximum throughput can be get when G value is 1 by 2. So we substitute the value over here. So what we will get, that the throughput S is equal to 0.184. That is nothing but 18.4%. As we have talked in our previous slide, you can see This is what we are talking about, 18.4% in case of pure Aloha. Whereas in case of slotted Aloha, it is 36.8% when the value of G is 1 and the value of G, that is load overload function, that is 1 by 2. Yes. Please remember this part. Yes, any doubt in case of pure Aloha and slotted Aloha? Yes, class. Otherwise, we will move topic, that is CSMA.
सर न्यूमेरिकल सर वो स्लॉटेड लोहा का
Slotted
फॉर्मूला
Aloha का
लगा के
फॉर्मूला क्या लिखवाया मैंने अभी आपको,
G into E 2G बना
है ना? And we all know in case of slotted Aloha when it is maximum, when the value of G is how much? 1, right? So if we
Okay.
substitute the value of G is equal to 1, what is the value of S then? The efficient that the maximum throughput S will be 1 into E raised to power minus 2 G, that is again 1, not 2, it is only G, so it is 1, right? So what will come? That will come in case of slotted Aloha, it will come how much? If we substitute the value of G in this formula, you can see that 1 into e raised to power minus 1, right? Since it is slotted Aloha, so 2 will not come here, as we have discussed already. That is the difference between pure Aloha and slotted Aloha. In pure Aloha, we have minus 2G. In slotted Aloha, we have only minus G, right? And this derivation we have derived from the Poisson distribution, like the probability theory, where we have that Poisson distribution. From there, please don't go for the derivation. Just remember this particular for your numericals, right? Till now, we don't have any question, not a single question of Aloha in GATE exam. So this topic is not so important, but yes, you must know this thing, right? It can be asked